All right, welcome back. Unit D, Chapter 1, and we're on the lesson 1.2, Solar Fuel from the Past. So, there's quite a few overlapping outcomes from the previous lessons, but this lesson is focusing on fossil fuels. So, and when I say solar energy from the past, we're talking about the sun's energy that's gone into living things. They've died a long time ago and created these fossil fuels and turned into fossil fuels. So let's just look first off, the original source for almost all of the energy. There'll be a couple exceptions to this rule, but for almost all the energy that we use is the sun. Okay, so all of the energies we're going to talk about in this lesson all originate back to the original source of the sun. And in the sun, the original source is nuclear reactions, right? So those nuclear reactions that we talked about briefly in Unit C in the sun's core are emitting the EMR, the electromagnetic radiation. And most specifically, well, you've got the infrared heat, but you also have the light energy, right? The visible light, the solar, radiant solar energy that the plants need in photosynthesis. Right. Okay, so that light coming from our sun, from the nuclear reactions in the sun's core, allow plants to do photosynthesis, where they're taking the carbon dioxide, combining it with the water to produce your sugars and oxygen, and basically build up the plant and survive. So now only a small portion of the sun's energy is actually used for this photosynthesis. There's also a portion of the sun's energy that's used to drive the air currents, and those air currents we use and capture in the wind turbines that we're going to be talking about in the second chapter. And they also, all that heat that is coming from the sun is used to drive the water cycle. You remember the water cycle. You've probably done the water cycle a million times, right? You start that in like grade 4. You got your water, it evaporates into the clouds, it condenses in as rain or precipitation into the rivers and then go back into the water. So the only reason the water can evaporate is because of that sun's heat, right? Coming down. So again, the sun, original source for all the energy that we're going to be talking about, except one later on that I'll mention. Okay, so first source of energy we're looking at in this section. So in this lesson, we're looking at fossil fuels and also wood. So these are all sources that are coming from originating from the sun. Okay, so wood is like the original energy source for humans all around the world. They're looking for something to burn, to create warmth, and to cook. Okay, so we as humans have taken and harnessed that chemical potential energy. So it's chemical potential energy that's in that wood. Okay, and that came from photosynthesis. Right? That wood or that tree could not have grown without the sun. So that's how we're linking everything back to the sun. So the wood grew through photosynthesis from the sun. The light and heat from the wood fires enabled First Peoples and others to inhabit colder regions on the planet, like those forests in northern Alberta. It's still today, in most developing countries, the least expensive and most accessible method or form of energy. So it's still very widely used around the world. Unfortunately, wood typically leads to incomplete combustion. So you're going to get the release of the carbon monoxide, which you remember is quite poisonous. We have to be very careful about that. And polycyclic aromatic hydrocarbons. Remember those from your Unit B, your chemistry, and some other pollutants. So these PAHs are what cause the smog. Remember that? The low-lying smog. All right. Now, wood, the one awesome thing about wood, well, there's lots of awesome things about wood, but the big awesome thing is that it's renewable. Okay, so that's one of the reasons it's been used for such a long time, is that it can be replaced in a very relative short amount of time, right? A tree can grow, I don't know, 30 years, and you could be using that tree again, and cutting it down and burning it. Anyway, so that is considered renewable. All right, so then we're going to take it to the next step. So after wood, we basically could turn that wood into coal, right? So coal is just a much more compact and cleaner burning fuel than wood is. Coal also started through photosynthesis millions of years ago. So all that energy that was stored in plants was passed to animals when they were eaten, right? Eventually, both the plants and animals would die, and then because there's not a lot of oxygen, like in the oceans or whatever, the sediments would compact on top of them, and that heat and pressure over time is where we're getting the coal, petroleum, natural gases forming. Okay, and these are all called and referred to as fossil fuels. Now, these take millions of years to form. We cannot form these in our lifetimes. Millions of years to form, unlike a tree can grow within our lifetime. So because they take so long, these are considered non-renewable energy sources. So coal, non-renewable energy source. All right, so there's some images of coal over on the right-hand side. Coal has been a big part of Alberta's development over the last 150 years. You can see this very old picture, and I think it says Morinville, Alberta, of a coal mine near Morinville. Used to have coal mines in Edmonton and Calgary and all these different cities and towns, and they've moved outside the major cities a little bit more. But we'll look a little bit more about that in a second here. There's a few more. Okay. So coal in Alberta, commercial coal mines date back to the late 1880s. Alberta operates about 10 coal mines right now. Mind you, this number is changing, and you'll see why. It's changing quickly, actually. And Alberta contains about 70% of Canada's coal reserves, along with BC and Saskatchewan, accounts for almost all the country's coal production. Coal provides Alberta, well, in 2018, it provided 43% of Alberta's electricity. But as I said, things are changing very quickly. Coal is also exported by rail, so by train from here to British Columbia, and then it's shipped to Asian countries. It's heavily used in Asia for their electricity production. So the coal reserves in Alberta are found on the plains. There you can find strip mining and open pit mining. So it's most near the surface. And then the coal can also be found in the foothills and the Rocky Mountains, where they have surface and underground mining as well. The largest open pit coal mine in Canada is the Highvale mine, and it covers about 125 square meters west of Edmonton near Wabamun Lake. And there's a map of it here, actually. So there's Wabamun, if anybody's been camping there or anything. All these are different pit mines all along the side here, along the river. There's the North Saskatchewan River as well. Now, what's really interesting is coal is all over the news right now. I don't know if you've been listening to any of the news, but there's a lot going on with the coal industry. So that Highvale mine that I just pointed out is the largest one. It's also going to be closing right now, actually in this year. They're going to stop using coal TransAlta isn't going to use coal anymore to generate power in Canada, effective January 1st, 2022. So Alberta made a deadline to stop the use of coal by 2030 because it is very high polluter of greenhouse gases when coal is burned. There's a lot of carbon dioxide released. So this is one method of reducing our carbon dioxide really. Just one way to meet our targets to reduce carbon dioxide in Alberta is stopping burning of coal for electricity. So a lot of these mines are going to be shutting down. And what are they going to be replaced with? Well, instead of burning coal, we are going to be replacing them with natural gas. Remember when we were looking at the amount of coal, or what was where our electricity in Alberta was coming from? Well, about half of it was coming, or 43% from coal, and the other 40-something% was from natural gas. So I imagine now you're going to start to see that number be closer to like 80% natural gas is our source of electricity in Alberta. We'll see how that works in the future. So we're moving there very quickly. However, there's some interesting headlines and some controversy now. And I like this headline here. It's kind of interesting. You can't kick coal power habit at home, but keep exporting it. So we are still exporting a lot of coal to other countries so that they can burn it for their electricity. And here's a picture of coal terminals in BC, and you can see all this is coals here, coal piles and piles of coal, and these are all those little giant shipping containers, I should say. So they look small here, so you can get a sense of the size and the amount of coal that is being shipped out. I also started like a few months ago, there was big controversy because they had started allowing more coal exploration in Alberta in the foothills, and that has been stopped right now due to a lot of pressure from Albertans. But interesting that we're going to stop using this coal for burning for electricity in Alberta, but we are still shipping it out to other countries to do it. Very interesting. Anyways, a good thing to go and take a peek at. Fossil fuels. So next one we're going to look at quickly is natural gas. So again, natural gas is a fossil fuel, so it's from organisms that were in the ocean, plants, animals that died, and eventually, over time and pressure, turned into natural gas. This gas gets trapped in between the different bedrocks, different types of rocks. You can see a picture of it. There's some gas right there trapped. And so the companies will drill wells to get down to that gas. If it's conventional gas, it's pretty straightforward. The well goes down and then a hole goes down, and then the gas is pumped right up. You can also have unconventional gas as well, and this is where a bit more of the controversy comes in with drilling, and you've probably heard the term fracking before in the news. And to get this unconventional gas, you have to do some horizontal drilling, very deep down, and they're basically drilling into the wells and making little fractures and then pumping this liquid in, which causes these fractures and cracking. And I'll let you watch the video that's on the next slide, but there's a lot of controversy around it and the fact that it may be causing earthquakes to be happening in localized areas from this fracking. Yes, there we go. Yes, so this is the video. This is a great video on Natural Gas 101. It goes from the creation of natural gas all the way to its uses and how it's delivered to where it needs to go. Couple key points from this video that when natural gas is burned to create electricity, it releases 50% less carbon dioxide than coal. So one of the reasons that we want to use this instead of burning coal, a lot less pollution. However, we have to be really careful because methane itself, when it's released into the atmosphere, is actually 24 times worse of a greenhouse gas than carbon dioxide. It's that much more damaging. So leaks are really bad for our environment, but also when the gas leaks, it's very toxic to humans and dangerous because it can explode and it can actually kill us. So we have to be very careful with methane or natural gas. This also is an excellent video I need you to watch. This reviews how fossil fuels are created, but then it goes into a discussion about how much fuel is actually, like how much fossil fuel is actually left in the world for us. And then even if we use these new and different technologies to extract the fuels, what are some of the advantages of those and disadvantages? And then it also does a quick review of the greenhouse effect, which I think some of you might need in case you don't remember that, how that works. And then questions. Maybe we don't want to burn all the fossil fuels, even if we have them left for another 100 years or so. Alrighty, now this is the other piece that you need to know. We're going to be referring back to this later on. Every time we learn about a new electricity source or energy source, we're going to see how that energy is turned into electricity. So this image, there's another image like this on page 500 in your textbook. I suggest reading through this. I know that page is not in this lesson, but I'm pulling it into this lesson because it flows nicely. So how do we go from getting coal, there's our coal, to getting electricity, which is what we're needing. So this process is very similar for all the different types of energies. There'll just be slight differences. So in this case, coal is burned. That's step number 1. You burn the coal in a boiler here. Okay, so you create a really hot environment. Then you pump water in so that the water can boil in this hot environment. So it's boiling. So that's step number 2. Boils the water. Step number 3, the boiling water turns to steam. And the steam or water vapor goes and turns the turbine blades. This should seem a little bit familiar if you remember. Generators. Okay, so our turbine is connected to the generator. So the turbine is being pushed by the steam on those blades, just like a windmill, right? Which is attached to the generator, which is turning around magnets. It's got coils. Remember the coils in a magnetic field in between magnets. And because it's turning wires inside a magnetic field, you get electricity coming out. So you're step 6. So it turns the generator and then creates electricity. Now, you do need to know these chemical, the conversions that are happening, what you're starting with. So coal is a chemical energy. Now, we can go even further back with coal because you know that coal came originally from animals and plants, right? And plants needed to get, so the plants are also chemical energy, but how did they get their chemical energy? They got it from photosynthesis, from the sun, right? And how did the sun get its chemical energy? Remember, think nuclear core, nuclear reaction in the core. So really, coal, this whole electricity being produced by coal can get transferred, you can find your path all the way back to the nuclear reaction in the sun. Okay, so let's start here again. So we've got our coal, it's our chemical energy. It's being burned and transferring the heat to the water. So we've got thermal energy here, thermal energy transfer. That thermal energy from the steam is being used to turn a turbine. As soon as you're turning something, that's mechanical energy. And then you're turning that generator, which is producing the electrical energy. So we've got chemical going in with the coal and electrical energy coming out. Now, a great review. Again, it's going to go through all these same steps I did. Watch this. It also connects to how transformers then take this electricity. And remember, that's from Unit C. So there's great connection to Unit C as well in this video. And that is the end of this lesson. Make sure you go back and watch all those wonderful videos.